I've walked into houses where a $2 piece of brass took down an entire ceiling. Not a hurricane, not a burst pipe from a hard freeze, just a little shut-off valve under a bathroom sink that somebody installed wrong 10 years earlier, and it finally gave up on a random Tuesday while the homeowners were at work. By the time anybody found it, water had been running for probably 6 or 7 hours. The drywall in the kitchen below was bulging like a water balloon. The cabinets were swollen shut, and when the adjuster and I pulled that valve out from behind the vanity, I could see exactly what happened. Somebody had torqued that compression nut down like they were trying to win an arm wrestling match, cracked the ferrule, and it had been weeping, just a slow drip for who knows how long before it finally let loose. That family ended up with about $18,000 in damage from a valve that costs less than a fast food value meal. New subfloor, new cabinets, new drywall, a couple weeks in a hotel while the drying equipment ran around the clock. All from a part smaller than your fist. And the part that always got me in 30-some years of doing this job is that installing one of these things correctly takes maybe 20 minutes. You don't need a plumbing license, you don't need special training, you just need to know the handful of things that actually matter and skip the stuff that doesn't. So here's exactly what we're covering today. I'm going to show you how to replace an old shutoff valve on copper pipe with a new one the right way, whether you go with a compression valve or a push-on shark bite style valve. You'll see the exact tools I use, what they cost, and where I get them. I'm going to show you the one tool that makes removing that old compression ring almost effortless, instead of fighting it with a hacksaw for 45 minutes like most guys do. I'll walk you through prepping the copper pipe so your new valve actually seals instead of weeping for the next 5 years. And I'm going to cover the supply line itself because I'd guess close to half the leaks I got called out for over the years didn't even start at the valve. They started at that cheap little plastic supply line connecting the valve to the toilet or the faucet. By the end of this, you'll know exactly what a job like this should cost you if you do it yourself, what a plumber typically charges for the same 20-minute job, and the 3 mistakes that cause a brand new valve to start leaking 6 months down the road when everybody's already forgotten they even touched it. My name is Frank. For a little over 30 years, I worked as an emergency mitigation and repair technician, contracted through home insurance companies. That means when a house got hit, a storm, a fire, a flood, a pipe that let go in the middle of the night, I was usually one of the first people through the door. Before the adjuster showed up to write the claim, before the real contractors came in to do the rebuild, my job was to stop the bleeding, stabilize whatever was falling apart, keep a bad situation from turning into a total loss, and buy the homeowner some time. When you do that for 30 years, you see the same failures over and over again. And shut-off valves and supply lines, I can't even count how many times those two things were sitting right at the root of the damage I was called out to fix. Old age, sure, sometimes. But more often than not, it was somebody who installed it wrong the first time and never knew it. Now, here's the injustice part of this. And it's not some big conspiracy, it's just how things play out. Most homeowners either pay a plumber $150 to $250 to swap a valve that takes 20 minutes and about $15 in parts, or they try to do it themselves, get it just wrong enough, and end up paying for it later in a much worse way, sometimes years later, when they've completely forgotten they ever touched that pipe. Nobody's out here trying to rip you off on purpose. It's just that nobody ever sits down and shows the average homeowner the 2 or 3 details that actually make or break this job. That's what we're fixing today. Stick around to the end, because I'm also going to tell you the one thing almost nobody checks after the job's done. And it's the difference between finding out about a slow leak in 24 hours instead of 24 months. Here's what most people get wrong, and it's not what you'd think. It's not the valve itself. Most valves, whether it's a cheap one or an expensive one, will do their job fine if they're installed correctly. The mistake is almost always in how the copper pipe gets treated during the swap. People yank the old valve off with one wrench, twisting and torquing on that copper stub sticking out of the wall, not realizing there's a solder joint back there they can't see, sometimes just a few inches behind the drywall. You put enough stress on that pipe from the front, and you can crack that joint loose without even knowing it. Then, months later, water's trickling down inside your wall, and you've got no idea why, because as far as you know, you never touched anything back there. That's the number one thing that turns a simple valve swap into a 5-figure insurance claim. So before we get into anything else, that's rule number 1. Whatever you do, don't let that copper pipe twist. All right, let's get into it step by step. Before you touch a single tool, you need to shut off your water. If your house has a main shutoff valve inside, in a basement, a utility closet near the water heater, use that one. If you're in an older home and you don't have an accessible interior shutoff, you're going to need to shut it off at the meter, usually out near the street or at the edge of your property. Turn it until it stops. Don't force it past that point. Once it's off, go find the lowest faucet in your house, a basement laundry tub or a first floor bathroom, and open it up. That drains the standing water out of your pipe so you're not getting sprayed in the face when you pull the old valve. If water is still running steady out of that faucet after a minute or two, stop what you're doing. That means your main isn't fully shut and you need to go back and find the real shutoff before you go any further. For this video, I'm covering copper pipes specifically and the two valve types you'll run into most as a homeowner: compression valves and push-on shark bite style valves. If you've got PEX pipe or a soldered valve, that's a different process and I'll cover that one separately, so if that's your situation, hang tight for that one. Once your water's off and drained, it's time to pull the old valve. This is where I want you to slow down. Use two tools, not one. One wrench holds the valve body steady, the other loosens the nut. If you only use one wrench, you end up twisting that copper stub, and like I said, that's how you crack a solder joint you can't even see. I like using a basin wrench for this part because it grips the body of the old valve without letting it slip, especially in a tight cabinet where you can barely get your hand in there, let alone two tools and both your arms. Now, once you've got the front part of that old valve off, here's where most DIY ears get stuck. There's still a compression ring left on the pipe, sometimes called a ferrule. This is the little brass ring that actually creates the seal. A lot of people try to cut it off with a hacksaw, which is a great way to nick your copper pipe and ruin it. Others try to twist it off with a wrench. And that's just as bad because that ring is built to grip that pipe hard, and forcing it usually deforms the copper underneath it. What you actually want is a tool called a ferrule puller, sometimes sold as a compression ring puller. I picked mine up for around $15, and honestly, it's one of the best $15 tools I own. I'll drop a link down in the description if you want to grab the same one I use, or you can find one at just about any hardware store or home center. Here's how it works. Spray a little silicone lubricant on the threads first. It helps things turn smoother. Slide the puller onto the copper pipe. Take the old nut that's still sitting on the pipe from the original valve and thread it onto the back of the puller. You might need to back the puller's screw handle out a bit to make everything line up. Once it's threaded on, just start turning the handle and it'll draw that compression ring right off the pipe, nice and clean. If the whole puller starts spinning instead of the handle turning, just grab it with an adjustable wrench to hold it steady while you keep cranking. I've used this thing probably 200 times over the years, and it comes off clean almost every single time without putting a scratch on the copper. Once that ring's off, take a good look at the pipe underneath it. This step right here decides whether your new valve is going to hold or whether you're going to be back under that sink in 6 months wondering what went wrong. The copper needs to be clean, round and smooth, no dents, no gouges, no burrs. If the old valve was installed wrong to begin with, or if you nicked the pipe pulling that old ring off, that section's got to go. Grab a pipe cutter and cut off the damaged section. Just make sure you leave yourself at least 1.5 inches of clean pipe sticking out past the wall or the finished surface, so you've got enough to work with. Cut it too short and you won't have anywhere to seat the new valve properly. After you've got clean pipe to work with, take some fine sandpaper or emery cloth somewhere in the 150 to 180 grit range and clean up the surface. You're getting rid of any burrs, any oxidation, any grime, anything that would keep that new compression ring from sitting flush and sealing tight. I've also got a little wire brush fitting I use for this. If the pipe's not caked with old solder, it makes quick work of it. Either way, the goal's the same. Smooth, clean copper all the way around. Before you slide that new valve on, this is your moment to install an escutcheon. That's the decorative metal or plastic collar that covers the hole in the wall or floor where the pipe comes through. Get one size for 1/2-inch pipe. Metal ones hold up a little better over time, plastic ones won't ever rust, so it's really just personal preference. If you forget this step, don't panic. They do sell split escutcheons that snap on after the fact, but it's a lot cleaner to just do it now while the pipe's bare. Now, let's talk about the compression valve itself, because this is the one I install most often on copper. Order matters here, so pay attention. First, slide on your compression nut, then the new ferrule, then finally the valve body itself. Push the valve all the way onto the pipe until it seats firmly and stops. This next part is the moment where most leaks get born, so slow down. Hold the valve body steady with one wrench while you tighten the compression nut with the other. I don't like clamping directly onto the new valve body with a wrench. It scratches up the finish and can even mess up the threads where your supply line's going to connect. I use a strap wrench or a valve socket that threads right onto the outlet side, so I'm not marking up the valve at all. Here's the exact technique. Tighten that nut by hand as far as it'll go. Then with a wrench, give it another 1/4 to 1/2 turn, no more. That's it. You do not need Teflon tape and you do not need pipe dope on a compression fitting. I know that surprises some people because we're all trained to think more sealant equals fewer leaks, but on a compression joint, the metal-to-metal squeeze of that ferrule against the pipe and the valve body is what creates the seal. Tape or dope in there can actually get in the way and cause problems instead of preventing them. Now, let's talk about the other option, the push-on shark bite style valve. These things are fast, and for a lot of homeowners, they're a great option, but only if you get a couple of details exactly right. First, your pipe cut has to be clean and square. No jagged edges, no dents, no angle to it. Second, and this is the one people mess up constantly, the valve has to be pushed on completely. Check the packaging, it'll usually tell you the insertion depth. On 1/2-inch copper, it's typically around 1 inch. I actually take a marker and measure that 1 inch out on the pipe, and make a visible mark. Because when you're pushing that valve on, it can feel fully seated when it's really only about halfway there. Wiggle it a little as you push and keep pressing firmly until the back edge of the valve lines up with that mark. If it's not fully seated, it will leak. Maybe not today, but eventually. I actually cut one of these valves in half once just to show people what's happening inside because it helps to see it. There's a rubber gasket in there that creates the actual watertight seal against the pipe, and a ring of metal teeth, sometimes called flanges, that grip the copper and keep it from pulling back out under pressure. And yes, before anybody asks, these are code compliant. My only real gripe with them is that the valve body itself can spin a little on the pipe when you go to operate it. So when you're turning it open or closed, you sometimes have to brace it with one hand while you turn the handle with the other. That's not a big deal if you're standing in an open utility room. It's a real pain in the neck when you're crammed behind a toilet or reaching blind under a sink with both arms already full. Whichever style you choose, compression or shark bite, I tell you to spend the extra couple of dollars and get a quarter-turn ball valve instead of the old multi-turn gate-style valve. Ball valves seal fully with a quarter turn of the handle, they last longer, and when they say they're shut off, they're actually shut off completely, not just mostly. Just double-check the packaging says it's rated for copper pipe before you buy it. Once your new valve's on the pipe, let's move to the supply line, the little flexible hose that runs from that valve up to your toilet or faucet. If what you're replacing is one of those thin plastic supply lines and you'll know it when you see it, get rid of it. Those things are brittle, and I've seen them crack just from somebody bumping a bucket against them while cleaning under a sink. When they go fast, and you end up with water spraying everywhere in about 2 seconds flat. I always use braided stainless steel supply lines instead. They cost a little more, usually somewhere around $8 to $15 depending on length and brand, but they're far more durable, and they'll typically outlast the plastic ones by years. Now, the two mistakes I see constantly on supply lines. Number one is Teflon tape. Don't use it here. If you look closely at the fitting end of a braided supply line, there's a rubber gasket built right into it that creates the seal against the valve outlet. Wrap that thread in Teflon tape, and you can actually stop the fitting from turning far enough to compress that gasket properly, which means it won't seal right. And frankly, trying to wrap tape around a fitting while you're upside down, reaching behind a toilet, is nobody's idea of a good time. Mistake number two is over-tightening. People get in there with a wrench and crank it down like they're trying to make sure it never comes loose again, and all that does is crush and damage that internal gasket, which causes leaks down the road, sometimes not right away, but eventually. The correct method is exactly the same as what we did on the valve. Hand tight first, as far as it'll go, then just a quarter to half turn more with a wrench. That's genuinely all it takes. Once everything's connected, slowly turn your main water supply back on. Don't just crank it wide open right away. Ease it back on and give the system a chance to fill and pressurize gradually. Then check everything for leaks. I like to fold a paper towel and tuck it right under the new connections, then leave it there for a full day. If there's even a small drip, that paper towel will show it, sometimes before you'd ever notice a wet spot with your eyes. Run your hand along the underside of the fittings too and feel for any dampness. That one extra day of checking is the difference between catching a problem immediately, while it's still a 5-minute fix, and finding out about it 8 months later when there's already water damage behind your cabinet. Let's talk for a second about why this actually works. In plain terms, no engineering degree required. A compression fitting seals because that brass ferrule gets physically squeezed between the pipe and the inside of the valve nut, deforming just slightly to create a metal-to-metal seal with no gaps for water to sneak through. That's why a clean, round, undamaged pipe matters so much. Any imperfection in that surface is a path for water to escape. On a push-fit valve, the seal comes from that rubber gasket compressing tightly around the pipe, while the metal teeth behind it physically grab the copper to resist the pipe being pushed or pulled back out under water pressure, which typically runs somewhere between 40 and 80 pounds per square inch in a normal home. And on both supply line connections, it's a rubber gasket doing the sealing, which is exactly why over-tightening or taping over it causes more problems than it solves. None of this is exotic. It's just physics doing what it's built to do, as long as you don't fight against it. Temperature plays a role too. Copper expands and contracts a little as your water heats up and cools down, and that's part of why a joint that's slightly out of round or scratched up will eventually work itself into a leak, even if it looked fine the day you installed it. A clean, properly seated joint handles that movement just fine decade after decade. A rushed one doesn't. I also want to be straight with you about where my knowledge stops. I'm not a licensed plumber, and I'm not an engineer. Everything I've told you today comes from decades of hands-on fieldwork, seeing what holds up and what fails, not from a textbook. This particular job, replacing a valve and supply line, is well within reach for most homeowners. But if you're dealing with gas lines or a main water line that requires cutting into a wall with structural framing or anything involving your electrical panel while you're in there, that's when I'd tell you to call a licensed professional. Know where your own comfort level ends and don't be afraid to draw that line. There's no shame in it, and a good tradesman would rather get called for the right job than clean up after somebody who tackled something they shouldn't have. Now let's talk money, because this is where doing it yourself really pays off. A plumber coming out to replace a single shutoff valve and supply line is typically going to run you somewhere between $150 and $250, sometimes more depending on where you live and whether it's an emergency call. Doing it yourself, you're looking at roughly $15 for the ferrule puller, which you'll use again and again for years, somewhere around $8 to $12 for a quality quarter-turn ball valve, and another $8 to $15 for a good braided stainless supply line. All in, you're spending somewhere around $30 to $40 total for a job that would have cost you 5 to 8 times that much to hire out, and that ferrule puller alone will pay for itself the very next time you do this somewhere else in the house. I'd also tell you to skip the gimmicky products you'll see marketed for this kind of job. The spray sealants that promise to stop a leaking valve without replacing it, the pipe repair tape that claims to fix a cracked fitting permanently. I've pulled those things off of failed repairs more times than I can count. They might buy you an hour or two in an emergency to get water shut off safely, but they're not a real fix, and they usually just delay the inevitable while making the eventual repair messier. Spend the $30 or $40 and do it right the first time, and you genuinely won't have to think about that valve again for many years. If you'd rather fix it yourself than pay someone else to, hit subscribe and give this video a thumbs up. It genuinely helps me keep making videos like this one for you. I've also put together a free home repair guide with checklists, tool lists, and the core fixes every homeowner should know how to handle themselves. It's linked right down in the description below, and it covers a lot more ground than just what we talked about today. So here's what I want you to do this weekend. Walk around your house and check every shutoff valve you've got, under every sink, behind every toilet, at your washing machine, at your water heater. Try turning each one just a little to make sure it actually moves and actually shuts off water when it needs to. If you find one that's frozen up, corroded, or that's got one of those thin plastic supply lines hanging off it, that's your project for the weekend. Pick up a ferrule puller, a quarter-turn ball valve, and a braided stainless supply line, all in for under $40, and go handle it using exactly what we covered today. Shut the water off, drain the line, pull the old valve with 2 tools so you don't twist that copper, clean the pipe until it's smooth, install the new valve hand tight plus a quarter turn, and finish it off with a proper supply line, no tape, no over tightening, then put a paper towel under there and check it in 24 hours. That's it. That's the whole job, and now you know how to do it right instead of hoping it works out. Let me know down in the comments, what's the worst repair quote you've ever gotten for something that turned out to be this simple? I read every one of them, and I genuinely like to hear it. Next time, I want to show you how to handle this exact same job when you're working with PEX pipe instead of copper, because the tools and technique change quite a bit, and there are a couple of PEX-specific mistakes that trip people up even more than what we covered today. Fixing it right isn't about being fancy. It's about taking care of what you've got and the people who depend on you.